For controller of various PB, gain lines can be determined as in the following figure, where the controller input span is 100 degrees Celsius. The y-axis shows the output in percentage, and the x-axis shows the proportional band in percentage. Let's look at the first example, where for XP of 20% here, the gain is equivalent to 100 degree over 20, output over input. So the output is 100, the input is 20. So the gain is 5, that is represented by this slope. So 10% of error will result in 50% change in output. So we can see 10% of error here is 0%. So let's say 10% of error, it will result in 50% of controller output. In the second example, for XP of 50%, the gain is 100 by 50, which is represented by this second line. So for 10% of error here, the output will be 20% change due to the 10% of error. Same goes to the next one, which is gain of 1. 10% will cause 10% change in output. So 10% error will cause 10% change in controller output. And if we go further, we increase the proportional band up to 150%. The 10% change will cause a much more smaller, which is 6.66% change in output. So we can see here, as we increase the proportional band, we are actually reducing the controller output change, which makes the controller much more stable. But on the other hand, the controller will have very slow response to any changes or deviation from the set value. So in short, we can say the gain Kc is inversely proportional to the proportional band. Wide proportional band produce low Kc. Same goes to narrow band produce high Kc.